Hello students, how are you all? I am Gurmeet Singh and welcome you to CREATA classes and also welcome to our complete series on trigonometry for class 10 student. In this lecture or in this series, we will cover all these lectures using the power of visualization. You will love our unique way of teaching. Apart from this lecture, we are also having a complete PDF of the formula and concept list. Check out the link in the description. And we also have the cues related to the various trigonometric questions. To check the level of your understanding of the concept, check the link in the description. And especially in this lecture, we will cover the trigonometric identity. Most of the students find this topic as difficult, but I assure you after covering this lecture, the trigonometric identity will be handy to you. So without taking any further time, let's start with this lecture. Best of luck. In this chapter, we will cover the three trigonometric identities. These are the three trigonometric identities that we will cover. Trigonometric identities are just the simple equations involving the trigonometric ratios. These three equations are the trigonometric identities, and these three equations are very important and will remain with you for a long time. So don't skip any of the trigonometric identity or any of the topic related to trigonometry. It is really important. Further, these are the three equations that we will cover. The first is sine square theta plus cos square theta is equal to 1. The second is 1 plus tan square theta is equal to sec square theta. And the third is 1 plus cot square theta is equal to cosec square theta. These are the three equations. These three equations are also called the Pythagorean trigonometric identities. Why it is called? Because based on the Pythagoras theorem, we derive these three equations or these three trigonometric identities. So firstly, let's see how these three trigonometric identities are derived. We will also cover some of the previous concept. You can take it as a brush up. Before that, let's take the triangle ABC, which is right angled at angle B, and angle A is angle theta, which is a trigonometric angle. We have seen the formula of sine, cos and tan. Sine theta is perpendicular over hypotenuse, cos theta is base upon hypotenuse, tan theta is perpendicular upon base, and we have also seen tan theta is sine theta upon cos theta. Tan is sine upon cos. Further, we have also seen the value of cosec, sec and cot, which are reciprocal of sine, cos and tan respectively. So cosec will be reciprocal of sine, that is hypotenuse upon perpendicular. Sec is reciprocal of cos, that is hypotenuse upon base. And cot is reciprocal of tan, that is base upon perpendicular. Got it? These 6 formulas will be helpful in solving the 3 trigonometric identities. Here in this right angle triangle, firstly let's identify which is perpendicular, which is base and which is hypotenuse. Perpendicular is the side opposite to trigonometric angle, which is angle theta, so BC is perpendicular. AC is hypotenuse as it is opposite to 90-degree angle, and AB is the base. The same we have already covered in the previous lecture. If you want to revise, the link is given in the description. Let's replace perpendicular with BC, base with AB and hypotenuse with AC. Got it? Further, in the starting I have told you these equations are also called the Pythagoras trigonometric identities. What is Pythagoras theorem? It is AC square is equal to BC square plus AB square. So this is the Pythagoras. Based upon this theorem, we will derive the 3 trigonometric identities. Firstly, we will divide the Pythagoras theorem on left hand side and right hand side with AC square. Then we will divide on both sides with AB square. Thirdly, we will divide on both sides with BC square. By doing so, we will get our 3 trigonometric identities. Very simple. Just you have to take the Pythagoras theorem and you have to divide it with AC square. Then you have to divide with AB square. Then you have to divide with BC square. Then you will get the 3 trigonometric identities. Let's see. Firstly, let's divide it with AC square. Here AC and AC, it will be 1. BC upon AC will be sine, that is perpendicular upon hypotenuse, so it will be sine square. And AB upon AC, it is cos square, that is base upon hypotenuse. So we got our equation as sine square theta plus cos square theta is equal to 1. That is the first trigonometric identity. Very simple. Just we have taken the Pythagoras theorem and divided it with AC square, that is the hypotenuse square. Let's move to the second trigonometric identity. Let's divide the Pythagoras theorem with AB square. Here AC upon AB, it will be sec theta, that is hypotenuse upon base. So here we got as sec square theta, and BC upon AB is tan theta, that is perpendicular upon base. So we got here as tan square theta, and AB upon AB it is 1. So we got the equation as 1 plus tan square theta is equal to sec square theta. This is our second trigonometric identity. Let's move to the third trigonometric identity equation. Here we have to divide both sides with BC square. Let's see. Here AC upon BC is equal to cosec theta. Cosec, which is hypotenuse upon perpendicular. Here AC upon BC is cosec theta. So here it will be cosec square theta. And here BC square upon BC square, it will be 1. And AB square upon BC square, it is cot square theta. AB upon BC, it is cot, that is base upon perpendicular. So we got our equation as 1 plus cot square theta is equal to cosec square theta. This is the third trigonometric identity equation. Note that cot theta whole square is same as cot square theta. In the trigonometric term, we write square before the theta, that is cot square theta, or any of the trigonometric ratio like sin square theta. We do not write as sin theta whole square, it is sin square theta, just for the information. Simple, very simple. The proof is very simple. Just you have to play with the Pythagoras theorem. So these are the three trigonometric identity. Note that the first equation, that is sin square theta plus cos square theta is equal to 1, is valid for all the values of angle theta from 0 degree to 90 degree. Got it? Including 0 degree and 90 degree. The second equation, that is 1 plus tan square theta is equal to sec square theta, is not valid for 90 degree, because at 90 degree, tan 90 degree and sec 90 degree are not defined. So for not defined term, we are not defining this equation. So this equation is valid for all the angle from 0 degree to 90 degree, but not including the 90 degree. Got it? Why? Because tan 90 degree and sec 90 degree are not defined. Okay. Further, the third equation, 1 plus cot square theta is equal to cosec square theta. This equation is not valid for 0 degree. Why? Because at 0 degree, cot 0 degree and cosec 0 degree are not defined. Again, we will not define this equation for not defined value. So this equation is valid for all the angles from 0 to 90 degree, not including 0 degree. This is important and you should note it down. No need to note it down, just go to the description and download the complete formula and the concept list. The link is in the description. Further, let's check whether these equations are valid for trigonometric angles or not. Let's check for 30 degree. Sin square theta plus cos square theta is equal to 1. Let's check it out. Sin 30 degree is 1 upon 2 and cos 30 degree is root 3 upon 2. Let's put the value. On squaring, we got 1 by 4 plus 3 by 4. That is 4 by 4, which is 1. So left hand side is equal to right hand side. So for 30 degree, this equation is satisfying. You can take any of the trigonometric identity and any of the angles from the trigonometric ratio table. You will find that for all this equation, left hand side will be equal to right hand side. You can take any angle except the angle for the non-defined case that we have just discussed. Got it? On your notebook, you can try with angle like 30 degree, 60 degree, 45 degree for all the equations, whichever you are feeling comfortable, just for a practice case. Let's take some of the questions to see the implementation of these formulas. Before taking the questions, you should understand what formulas will be used. These three trigonometric identities formulas will be used. Apart from these formulas, the basic trigonometric ratios formula will also be used. That is, tan theta is sin theta upon cos theta, cosec theta is 1 upon sin theta, sec theta is 1 upon cos theta, cot theta is 1 upon tan theta. These formulas will also be used in solving the trigonometric identity question. So let's take these formulas on the side. Whenever we need this formula, we will take from this side. Okay, let's proceed with the NCERT example questions. Students, an important thing for you, check the description for the PDF of the complete formula list and also the link to the quiz. Use the formula list to brush up the concept before the exam and the quizzes to check your preparation before the exam. The link to both the formula list and the quizzes are given in the description. Check it out. So let's back to the lecture. Let's take NCERT example number 9. Express the ratio cos A, tan A and sec A in terms of sin A. Basically, we have to find the value of cos A, tan A and sec A in terms of sin A. Let's see. We know sin square theta plus cos square theta is equal to 1. Here angle theta or the trigonometric angle is angle A. So let's replace angle theta with angle A. We got sin square A plus cos square A is equal to 1. Firstly, we will write cos A in terms of sin A. So in this equation, we are having cos and sin. We can find the value of cos A in this equation, which will be in terms of sin A. Let's see. Cos square A, we can write it as 1 minus sin square A. So cos A will be equal to root of 1 minus sin square A. So cos A will be equal to root of 1 minus sin square A. So we have written cos A in terms of sin A. Got it? The first part we have done. Next, let's try to write tan A in terms of sin A. We know tan A is sin upon cos. That is, tan A is equal to sin A upon cos A. Here we have to write the tan in terms of sin. In the numerator we are already having the sin. Just we have to convert the denominator, that is cos A, in terms of sin. Let's replace cos A with root of 1 minus sin square A, the first part that we have proved. So we got tan A is equal to sin A upon root of 1 minus sin square A. That is the answer. We have converted tan in the form of sin. Got it? Next, sec A. Sec, we know it is 1 upon cos A. Sec is the reciprocal of cos. Further, we have just converted cos in the term of sin. Let's replace cos with root of 1 minus sin square A. So we got sec A as 1 upon root of 1 minus sin square A. So we have converted cos A, tan A and sec A in terms of sin. The conversion that we have done is very important. These type of conversion you have to do in the exam. Question may be slightly bigger. There you have to convert some of the trigonometric ratios in other trigonometric ratio form. Like here we have converted tan in the form of sin, sec in the form of sin. These type of conversion you have to do. And this is the beauty of NCERT question. They prepare you for the future questions that you have to do. Here you have done the conversion. The same you have to do in the actual exercise question. There, this conversion will be small part of the question. So these NCERT questions are preparing you for that big question. The NCERT question frameworks are really very good. Okay. Let's move to next question. Prove that sec A into 1 minus sin A into sec A plus tan A is equal to 1. Let's take the left hand side, the complete term. We will solve this with the help of the trigonometric formulas that we have seen and also the trigonometric identities formula, and we will prove this as equal to 1. Let's see. We know sec is a reciprocal of cos, that is sec A is equal to 1 upon cos A, and tan is sin upon cos. Let's replace sec A and tan A. Okay, we have replaced sec A and tan A. We have done this, so the complete equation is converted to sin and cos. Once we have converted to sin and cos, we can easily apply the formulas of sin and cos, which is the first trigonometric identity. So this is one of the trick. Just convert all the terms into the one type of trigonometric ratios as per the trigonometric identity formula. If you are using the first formula, just convert to sin and cos. If you are using the second formula, convert to tan and sec. If you are using the third formula, convert it to cot and cosec. Just a small tip how to approach the question. Further, let's take cos A as LCM. We got 1 plus sin A upon cos A. Cos A into cos A, it will be cos square A in the denominator, and 1 minus sin A into 1 plus sin A in the numerator. Here these two terms are resembling A plus B into A minus B, where A is 1 and sin A is B. So A plus B into A minus B, it is A square minus B square. So 1 minus sin A into 1 plus sin A, it will be 1 minus sin square A. And if you refer the first trigonometric identity, which is sin square A plus cos square A is equal to 1, here 1 minus sin square A is equal to cos square A. Let's replace 1 minus sin square A with cos square A. Here both the numerator and denominator will cancel out. We got the answer as 1, which is right hand side. Got it? That is the answer. What we have done, so how we have solved this question? Firstly, we have used a simple trigonometric ratio formula, that is tan theta is sin theta upon cos theta, sec is the reciprocal of cos, that is sec theta is 1 upon cos theta. We have converted the complete trigonometric equation into sine and cos form. Then we have simply solved the equation and we have used the first trigonometric identity formula and we have solved this equation. The same approach you have to use. Just note that only these formula will be used and these formulas will be used. Based on these formulas, you can solve any of the trigonometric identity question. As we will proceed, the hardness or the toughness of the question will further increase. Only the approach to be expert in trigonometric identity questions is to try more and more questions. The more questions you will try, the more understanding you will develop how to convert the equation into the different type of trigonometric identity. The more practice you will do, the more mastery you will get. This is the only approach to do the mastery over the trigonometric identity questions. So we have done with this question. Let's move to next question. Here we have to prove that cot A minus cos A upon cot A plus cos A is equal to cosec A minus 1 upon cosec A plus 1. Let's proceed with this question. Let's take the left hand side. Here in the left hand side we are having the term as cot and cos. On the right hand side we are having the term as cosec A, and cosec is the reciprocal of sine. So somehow if we are able to convert the left hand side in the term of sine, then we can do the reciprocal and we will get the cosec term. So this is the approach in which you have to think while seeing the trigonometric identity question. Let's see. Here cot we know is cos upon sine. Cot is the reciprocal of tan. Tan is sine upon cos. So cot will be cos upon sine. So let's replace cot A with cos A upon sine A in the numerator as well as in the denominator. Here in the numerator, let's take cos A as common, and in the denominator also let's take cos A as common. Cos and cos cancel out. We are remained with only sine term. And sine is matching with the cosec, that is a reciprocal. Here we can rewrite 1 upon sine A as cosec A. So we got our answer, that is cosec A minus 1 upon cosec A plus 1, which is the right hand side. Okay, we got left hand side is equal to right hand side. Do not blindly solve the question, just focus on how we are approaching the question. In this question we have converted all the terms into the sine term so that it can match with the cosec term. So try to learn and understand the different approaches. The more questions you will try, the more approaches and techniques you will understand. Okay, let's move to next question. Prove that sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1 is equal to 1 upon sec theta minus tan theta. And in the question it is also given we have to prove this using the identity sec square theta is equal to 1 plus tan square theta. That is the second trigonometric identity. Okay, we will use this. We have to convert the sine and cos in the left hand side into the sec and tan term, which is the right hand side. So the question is how we can convert sine, cos and the third term into sec or tan. What is the relation between sine and tan? We know sine upon cos it is tan and 1 upon cos it is sec. So if we divide the numerator and denominator with the cos theta, we will get sec and tan. Let's see. Let's divide the numerator and denominator with cos theta. Sin theta upon cos theta will be equal to tan theta, and cos theta upon cos theta will be 1, and 1 upon cos theta will be sec theta. Sec is the reciprocal of cos. So we got the equation as tan theta minus 1 plus sec theta upon tan theta plus 1 minus sec theta. So we are successful in converting the equation into the tan and sec term. The first hurdle we have crossed. Now we have to convert this equation into 1 upon sec theta minus tan theta, that is the right hand side. Let's see. Let's rewrite this equation as tan theta plus sec theta minus 1 upon tan theta minus sec theta plus 1. Let's multiply numerator and denominator with tan theta minus sec theta. Let's multiply tan theta minus sec theta with the complete term in the numerator, that is tan theta plus sec theta into tan theta minus sec theta, that is the first term, and further 1 with tan theta minus sec theta. What we have done, we have multiplied tan theta minus sec theta with the complete term. That is, we have opened the bracket. Tan theta minus sec theta with the first term and tan theta minus sec theta with the second term. The simple concept of mathematics we have applied. Okay, any confusion? Just simple multiplication we have done. Further, here tan theta plus sec theta into tan theta minus sec theta, it is resembling a plus b into a minus b, right? A plus b into a minus b, we know it is a square minus b square. So this term will be equal to tan square theta minus sec square theta. Okay, the simple formula we have applied. Further, if you refer the trigonometric identity formula, that is the second trigonometric identity formula, can we say tan square theta minus sec square theta is equal to minus 1? Yes, we can say so. Let's replace tan square theta minus sec square theta with minus 1. Okay, we got minus 1 minus tan theta plus sec theta in the numerator. Let's take minus common from this term. The numerator term and the denominator term, these two terms will be equal and will cancel out with each other. We got 1 upon minus tan theta minus sec theta. Let's multiply this minus into this term. We got 1 upon sec theta minus tan theta. That is equal to right hand side. Got it? How we have approached this question? Firstly, we have converted sine into the tan by dividing it by cos, and 1 into sec by dividing it with cos theta. 1 upon cos theta is sec theta, sine theta upon cos theta is tan theta. Further, we have used the trigonometric ratio. 1 plus tan square theta is equal to sec square theta. So with the help of these basic formulas, we have solved this question. Okay, got it? Interesting. The more question you will solve for trigonometric identity, the more you will be able to solve many questions. So students, that's it for this lecture. Hope you have enjoyed our creative way of teaching. If you have enjoyed this lecture, if you have gained anything out of this lecture, please like, share and subscribe to our YouTube channel, that is CREATA CLASSES. We add creativity to the learning. And note that this lecture is part of the complete series on trigonometry for class 10 student. The link to the other lectures are given in the description. Check it out. And apart from this, also check out the PDF of the complete formula and concept list, and also the quiz related to trigonometric questions, where you can check the understanding of the trigonometry and the questions. So that's it for this lecture. Bye for now. Best of luck for the exam you're preparing for and have a great day. Bye.